Section 1, Theory of Heat. Unit 2, Matter and Energy. Objectives. After studying this chapter, you should be able to define matter, list the 3 states in which matter is commonly found, define density, discuss Boyd's law, and state Charles' law. Objective continuation. Discuss Dalton's law as it relates to the pressure of different gases. Define specific gravity and specific volume. State 2 forms of energy important to the air conditioning, heating and cooling, and refrigeration industry. Yeah. Continuation. Describe, work, and state the formula used to determine the matter. We're recording.
Sorry.
Used to determine the amount of work in a given task to find horsepower. Convert horsepower to watts. Convert watts to British thermal units.
Matter, described as any substance that occupies space and has mass. Is made up of atoms, exists as a solid, liquid, or gas. The state of matter is determined by heat content of the matter.
Matter.
Matter matters.
Okay, check this out. I know some of you guys are gonna get this wrong on the test. So, pay attention, never fails, so. What's that say?
This
Solids.
block of ice exerts all the pressure downward.
Downward,
So ice will push pressure down.
yeah. The
Well,
weight of ice.
That makes sense, cause if I put an ice cube on my table and watch it, it's gonna melt down. Right, isn't that kind of the same thing?
That's not the same thing.
Well, it
You
kind
gotta
of,
talk about
A
that. at all.
solid, any solid.
oh, any solid, okay,
Any solid's gonna exert pressure downward,
okay.
okay? So any liquid is gonna exert pressure where?
Outward and down,
Down
Not
and
out.
out. Okay,
same thing. You just said out.
and downward.
Both.
Downward and outward,
Arrows.
okay?
Onward's a good movie.
Oh, wow, say that again, Steve, liquid what?
Liquid will go out and down.
Down and
Okay,
out.
a gas pressure will exert pressure
Everywhere, it's like.
in all directions, right?
kinda like
That's
when you
pretty,
fart, it just goes-
we need to go back over that, downward and outward.
No, we don't need to go over that. We're good. You get it, Victor?
It's in your PowerPoint, look
Solid?
at the pictures.
You guys are talking too much. Say that again, Steve. Liquid goes down. Down and out.
Down and out.
Down and out,
Okay.
that's where the pressure goes in liquid. Okay. And gas, all over.
You get it, Ricky?
Important definitions. Mass is the property of matter that responds to gravitational attraction. Weight is the force that matter, solid, liquid, or gas, applies to a supporting surface when it is at rest. Density is the mass to volume relationship. Water has a density of 62.4 pounds per cubic foot.
Very good.
Key definitions continued. Specific gravity is the density of a substance divided by the density of water. Specific volume is the volume of 1 pound of a gas measured in cubic feet per pound.
Okay. So we covered all this, right, last week?
Yeah.
Specific volume, remember that?
Specific gravity, example. Density of water equals 62.4 pounds per cubic foot. Density of aluminum is 171 pounds per cubic foot. Specific gravity of aluminum. Density of aluminum divided by density of water equals 171 pounds per cubic foot divided by 62.4 pounds per cubic foot equals 2.74. Specific gravity is unitless.
Unitless. Okay, so that unitless number, so so funny?
I
One
told
of
you
them
too.
too.
It was.
Oh, that's- okay. Specific gravity is unitless. Do I need to separate you two?
We are separated. Social distancing.
Okay, so what it's saying is it's compared to, what's the one constant that we know?
Water.
Water. That's the one constant that we always go back to, so it's comparing the density of water to the density of a substance, and that's gonna give us our specific gravity. You guys got that? Then we're gonna move on. So this is in the book, this table's in the book. So it could be on the test. It'll give you some of the densities of, some substances. Tungsten, water, gold, brass, aluminum. So it also gives you the specific gravity of those. Okay. You can see that in the book.
I'm looking for it right now.
I get the PowerPoint?
Yeah, you want PowerPoint?
Yes, please.
There's donuts over there too. Is that a coffee machine? Ray said we have to eat at least 6 more.
It's on page 31, just so you guys know.
On page 31. Okay. Alright, so you guys are gonna need to know these gas laws and the difference between all three of them, okay? Okay. Okay. What does that say? Can't read.
Gas law. Always use absolute pressure and temperature when working with gas law. Boiler law relates pressure and volume. Charles law relates volume and temperature. General law of perfect gas relates pressure, volume, and temperature. Dawkins law relates pressure of gas in a mixture.
Okay, so this is Boyle's law. No boilers, boilers, more,
Boiler.
Boyles. Boyles, Charles, and Dalton. Okay, so we're gonna walk through these and we're gonna discuss each one and what it means. That's Boyle's law. Okay? That doesn't make much sense, but this is what it is in reality. So, as the, let's say, as the volume decreases, the pressure increases. Okay, does that make sense? So, the pressure's gonna increase when the volume decreases. Okay, got that? Okay. Pretty simple, huh? Piston and pressure and stuff, yeah? Okay. Okay, so Charles' law deals with temperature and what is it?
Volume.
Temperature and volume. Okay. So as air gets heated, it gets bigger. So the air gets bigger. So that's an example of what Charles' law is. As it gets hotter, it gets bigger, takes up more space. Okay. So what was the first law?
Boyle's law.
Deals with what?
Pressure and volume.
Pressure and volume. Charles' Charles law deals with what?
Volume, temperature.
Volume and temperature. Okay? The general law of perfect gases is,
Relates to pressure,
All of them.
volume, and
there is
temperature.
there's no cartoon for that. We have to imagine it in our brain. That it's a combination of Charles and Boyle's law. Okay. And we have Dalton's law. Dalton's law says that the mixture of gases is the sum of each gas as far as pressure is concerned, like oxygen and nitrogen. Where do we find oxygen and nitrogen?
Air.
Air. Okay, so oxygen has 30 psi and nitrogen is 40 psi, so the combination, the sum of those two is gonna be the total pressure of both gases. That's Dalton's law. Dalton.
Energy. Electrical energy drives motors and pumps in HVAC/R systems. Energy cannot be created or destroyed, but can be converted from one type to another. Heat energy provides comfort, heating, flows from a warmer substance to a cooler substance. Electrical energy pushes by the kilowatt, fuel oil, by the gallon, natural gas, by the cubic foot.
Okay, so saying that energy cannot be created or destroyed. And, we talked about this, what did it say?
Heat
Hot,
energy provides
cold.
comfort, heating, flows from a warmer substance to a
Heat
cooler
energy.
substance.
Yeah, okay, alright. And what does that mean right there?
Kilowatt hours.
Kilowatt hours. How many watts in a kilowatt?
1,000.
Okay. Okay, so this cartoon is showing you that if you got 100 degrees there and 75 degrees there, heat's gonna go in that direction. See that? Yeah. Even if you got minus 200 and minus 350, heat's still gonna travel from
So it's gonna go
Warmer
to the colder
to a
side?
colder.
Yeah.
Oh, which makes sense, if I'm heating up my house, it's gonna,
Cause hot air attracts, goes to cold air. Right?
hot to cold.
Yeah, hot
Hot
to
to
cold.
cold.
See, they missed that. That's why we learned last. They need to play the song.
You need to play the song for them.
Hot to cold, and that's why it makes sense.
Down and out.
Work equals force times distance. Force is given in pounds, distance in feet. The units of work are foot pounds. Example, how much work is done to move a 150-pound object 100 feet? Work equals force times distance equals 150 pounds times 100 feet. 150 times 100 equals 15,000 foot-pounds.
Okay.
Power, the rate at which work is done. Work per unit time, foot-pounds divided by minutes. Rated in horsepower. 1 horsepower equals 33,000 foot-pounds per minute. Electrical power is measured in watts. 1 horsepower is 746 watts. 1 watt is 3.413 BTU. 1 kilowatt, 3,413 BTU.
Okay, so 1 horsepower equals 746 watts. You're gonna see that question a lot during your stay here. Okay? 1 watt equals 3.413 BTUs. You need to remember that for the rest of your life. Okay? So file it accordingly.
So we're gonna memorize what one for the rest of our life?
One watt.
One
One
watt.
watt.
equals-
And 1 horse.
Okay,
Might as well memorize that one too.
just memorize them all.
Yeah, you get them all down.
I think that's a great idea.
I think we should remember all of this stuff.
So here's your cartoon of a horsepower. As you can see, there's a horse
Pulling stuff.
pulling
Then just
a load, that's 1 horsepower. Uh-huh. What is that?
Summary. Matter takes up space, has mass, and can be given the form of a solid, a liquid, or a gas. Key terms: weight, mass, density, a specific gravity, and specific volume. Continuation. Key laws: Boyd law, Charles law, general law of perfect gases, and Dalton's law. Continuation. Electrical energy and heat energy are 2 forms of energy. Key measurements. Measurements of fossil fuel, natural gas, coal, and electricity. Work equals force times distance, horsepower, watts, BTU. The end.
It didn't say that.
I'm just letting
Making up
people know
words
it's
now.
the end.
Making up words.
Oh,